welcome to the course Excelling with Mathematical Modeling. Today we will be talking about an interesting social science problem, mathematical model of love affair. So, we call it a Layla-Majnu model, and this N is silent. So, this was first introduced, this kind of model, by Strogers in his famous book Nonlinear Dynamics and Chaos. And later such kind of modified model was given by Rinaldi in this particular paper. So, this model can be generalized for any famous couple like Romeo and Juliet, Cleopatra and Mark Antony. We call it a Majnu-Layla model or a Layla-Majnu model, which is taken from a romantic poem by Nizami of Ghanzi and inspired by an Arab legend. So, let us look into the model. So, it is a mathematical model of love affair. So, how do you define love or how you explain love? So, that can be referred to a variety of different feelings, states and attitudes ranging from generic pleasure to intense interpersonal attraction. So, we consider a mathematical model between two individuals in a romantic relationship. We call it Majnus. This N is silent, and Layla. So, we consider they are modern Laylas and Majnus. So, this is the rate of love for Majnu and this is the rate of love for Layla. So, on what these love depends? So, the first is on his own feelings. So, suppose a boy sees a girl and he started liking her. So, he is encouraged by his own feelings. So, that is taken care by this first term, the rate is A. Similarly, for the Laylas also, so she is first encouraged by its own feeling, which is at the rate C. And then how much he or she is encouraged from the feeling of the other opposite sex. So, in this case, what kind of signals this the girl sends? Suppose you look at her, whether she is looking back, you ask her for coffee, whether she is accepting or whether she is declining. That sort of encouragement is given by this particular term, which is happening at a rate B. The same goes for the Laylas also, that this is the part where she is encouraged by her own feeling, and this is the part where she is encouraged by Majnu's response to her feeling. Now, this is the interesting part, which we name them as, say, some function f and g. So, this is some sort of appeal. So, when in the very first a person, say the Majnus, look into the Laylas, so he must be looking how she looks or how she dresses, how she is carrying over any background from the family. So, those things are taken care by this appeal f. And in the similar manner, for the Laylas, other than the looks, they look for some social status, whether he owns a property or a car, how much money he can spend on a date. So, those kind of things are taken care by this function g. So, if you now want to look at a mathematical model, this will look something like this. So, where your MT, it represents Majnu's love for Layla and LT represents Layla's love for Majnu. So, the rate, so the model looks very simple. So, the rate of love for Majnu is A times M plus B times L plus F, and this is the dt of L, that is the rate of change for love for Layla for Majnu is C times L plus D times M plus G. So, this is the part where Majnu is encouraged by his own feeling, and this is the part where Majnu is encouraged by Layla's feeling. Similarly, this is the part where Layla is encouraged by her own feeling, and D is the rate at which Layla is encouraged by Majnu's feeling. Please note that I have not put any sign on A, B, C, D, F and G. So, the negative will mean that Majnu is discouraged by his own feeling. This is her. And this is, if this is negative, then Majnu should be discouraged from Layla's feeling. So, the positive and the negative sign here represents the love and the hate relationship. Now, let us look into the analysis. So, as explained before, this A, B, C, D's, they are the encouragement of a particular Majnu for his own feelings or encouraged by the Layla's feelings, and similarly C and D is the rate at which Layla is encouraged by her own feeling and encouraged by Majnu's feelings. So, as explained before, this F, it is the reaction of Majnu towards Layla's appeal. For example, how she looks, how she dresses, the way she walks and talks and so on. Also her social background. Similarly, G is the reaction of Layla towards Majnu's appeal. For example, other than the looks, whether he owns a bike or a car, the amount of money he can spend on a date, whether he owns a property or not, also the social background and etc. This can be also be positive and can be negative. Now, let us look into the analysis. So, you have dm dt equal to A times m plus B times L plus F and dl dt C times L plus D times m plus G. And let us call it as F1, call it as F2. If I want the equilibrium solution, it is going to be AM plus BL plus F equal to 0. I write this one first, DM plus CL plus G equal to 0. You can solve this by many methods. I use method of cross multiplication. So, M by L by 1 by. So, CF minus BG, DF minus AG and AC minus BD. So, basically when you do for L, you take this into this multiplied by this into this. When you do for L, you just revise this into this multiplied by this into this, I mean the coefficients, and this is 1 by this into this multiplied by this into this. And you get your M star is equal to CF minus BG divided by AC minus BD, and your N star L star equal to DF minus AG divided by AC minus BD. So, AC minus BD should not be equal to 0. And also this has to be positive, this has to be positive, then this also has to be positive. If they are negative, then this has to be negative, but this cannot be equal to 0. Now, let us look for the stability. So, here nothing has been told about the signs. So, the only condition you have to maintain that the denominator does not become 0, whereas the equilibrium solution can be both positive and negative, because the positive means the love and the negative will means the hate. So, for stability analysis, you have to find the Jacobian matrix, that is del F1 del M, del F1 del L, del F2 del M and del F2 del M. If you do that, you will be getting A, B, D and C. The eigenvalues will be given by this characteristic equation, and you will get A minus lambda B D C minus lambda equal to 0. If you expand them, it is lambda square minus A plus C into lambda plus AC minus BD equal to 0. Now, if I want this to be stable, both my eigenvalues should be negative. So, this is the sum of the roots, this is the product of the roots. If both the eigenvalues are negative, the sum of the root has to be less than 0 and the product of the root has to be greater than 0. So, this is the condition that this particular system representing the Layla-Majnu model will be stable if A plus C is less than 0 and AC minus BD is greater than 0. Now, let us look into various cases. Case 1. So, we took some arbitrary values of A, B, C, D, F and G. So, if you substitute, there is no A, B is some value, there is no C and there is no F, there is no G. So, you are left with B, which is the value 3 and D, which is the value 2, and you get this set of differential equation. Now, what does this mean? So, this means that the rate of change of Majnu's love, that is this one, depends on the encouragement of Layla, and the rate of change of Layla's love will depend on the encouragement of Majnu. If I want to see the dynamics, first I have to find the eigenvalues. So, it is going to be, so you can, if you just compare it with this, so this one is 0, so it is 0 minus lambda, then B it is 3, then comes this M which is D which is 2, and then this one again 0 minus lambda, and this is equal to 0. So, the coefficient matrix, if you write it first from here, it is 0, B, then D and 0. So, in this particular case it is 0, 3 and 2, 0, and hence the characteristic equation A minus lambda I is this. So, if I just solve this, I will get it in the form lambda square minus 6 equal to 0 and lambda equal to plus minus root of 6. So, the solution will be, say, mt equal to some a1 e to the power root 6t plus a2 e to the power minus root 6t. And if I want to find LT, then LT is nothing 1 by 3 ddt of mt and 1 by 3. So, I just differentiate, root 6 will be common. So, a1 e to the power root 6t minus a2 e to the power minus root 6t. As your t becomes large, from here you see that your mt is approximately going to a1 e to the power root t6, because this goes to 0, and similarly your LT, it goes to some constant a1 times e to the power root 6t. So, if we plot this with some initial conditions, so you will be getting something like this, that is some sort of exponential solutions which is exponentially increase. So, this is what we called exponential love. So, this kind of love generally it is seen at the school level or it is very early teen level, where they say I love you exponentially. Not a very realistic situation, but it happens, and hence this kind of dynamics you get from this love affair model when you put this particular set. So, what you are trying to do is you are choosing this the value of A, B, C, D's in such a manner that you can relate these cases to some real life scenario. Let us take the second case, where you have A equal to -2, B is 1, F is 2, C is -1, D is 1 and G is 1. You plug the values and you get something like this. Now, what does this mean? So, you can see that the rate of change of love for Majnu, it is a negative and then a positive. Similarly, for Layla also it is first negative and then positive. So, some sort of forgetfulness is appearing here, and this due to which the partner lose interest due to his or her own feeling. However, when there is a reciprocate from the other partner, then that love rekindles. So, this is the case in both this equation, and both of them have the positive appeal which also attracts towards each other. So, let us see what kind of dynamics this gives when you find the eigenvalues. So, your coefficient matrix A is going to give you -2, 1. So, here I have to write the m first because of this order. So, mt minus lt plus 1. So, it is 1 minus 1, and your A minus lambda I equal to 0 will give -2 minus lambda 1 1 minus 1 minus lambda. If I simplify this, it is lambda plus 2 into lambda plus 1 minus 1 equal to 0. So, lambda square plus 3 lambda plus 2 minus 1 equal to 0, and you get the values of lambda from here. So, lambda is -3 plus minus b square minus 4ac divided by 2a. So, -3 plus minus root 5 by 2. So, this root is also. So, this is -3 plus minus, this is approximately 2.24 divided by 2. So, what I am trying to show is that both the values lambda 1 and lambda 2 are less than, if you take the modulus, both the eigenvalues are less than 0, and hence the system is stable. Now, let us look into the interpretation of this model. So, as I told you that -2 mt, this will mean that some forgetful or forgetting process which give rise to loss of interest in the partners. And this kind of behavior generally is seen in a long distance relationship, where some sort of out of sight, out of mind kind of thing happens, and the partners lose interest from their own feeling. However, if there is a response from the other partners, then the love blooms again and your relationship continues. And this instinct is sensitive to partners' appeal, as both of them are positive. So, in this, if you plot the graph, you will get this kind of dynamics, which says that you start with some sort of relationship and slowly their love grows and ultimately it becomes a plateau. So, the take home conclusion is that this kind of model, it describes a romantic relationship for cautious lovers with a positive appeal, which are capable of establishing a steady love relationship, as you can see from the graph. Now, let us take another case where A is 0, B is 3, F is 0, C is 0, D is minus 2 and G is 0. So, if you pluck all these values here, you get your differential equation like this. Now, what does that mean? So, here it means that the love of Majnu is encouraged by the feeling of Layla because it is positive. However, we use the word Layla is a fickle lover. So, you can see that the more Majnu loves Layla, but since it is a negative sign, she runs away and hides. So, the appeal from the person Majnu does not affect Layla. So, basically it's some sort of hating kind of relationship and we call it a fickle lover. So, if I want to see the dynamics of this kind of model, so first I have to find the eigenvalues and your coefficient matrix or Jacobian matrix will be this is 0, this is 3, this is minus 2 and this is 0. So, your A minus lambda I is going to give you 0 minus lambda 3 minus 2 0 minus lambda equal to 0, and this is lambda square plus 6 equal to 0. So, lambda equal to plus minus I root 6. If I want the solution, then your MT will be some C1 times cos root 6 t plus C2 times sine root 6 t. I could have written this as L also, really does not matter, but then I have to calculate the M from here. So, here M I have written this. So, L will be 1/3 of ddt of mt, which is 1/3, then root 6 will come out. So, minus C1 sine root 6t plus C2 cos root 6t. So, this is the two solutions and where C1 and C2 are arbitrary constants. Since it contains the sine and cos, obviously there will be a periodic solution. Suppose you want to put a initial condition, say your M0 is 1 and your L0 is equal to 0. So, if you substitute these two values, you will see that you get your MT to be equal to cos of root 6 t and your LT is minus root 6 by 3 sine of root 6 t. Now, we plot them. So, if you plot them, so once more time what you see here is that the love of Majnu is encouraged by the feeling of Layla. So, if she loves him back, his love warms up, and if she does not, he grows cold. On the other hand, your Layla is a fickle lover. So, the more Majnu loves her, she runs away and hides. However, Layla finds it strangely attractive when Majnu gets discouraged and backs off, and that explains this negative sign. So, if you plot this, you will get a curve like this. So, according to this initial condition, this must start from here, but the dynamics will remain the same. So, you can see that there is a love-hate kind of relationship that goes on between Layla and Majnu. Now, if you want to eliminate t from here, you will get something like mt square plus 3 9 by 6 LT square equal to 1. So, some sort of ellipse which you get. So, if you plot that and then try to explain, you can see that your Majnu and Layla, their love will be positive in only this one quadrant. So, 1/4 of the time is where both of them love each other. However, in all the 3/4 there is a love-hate relationship. Mainly this is love and hate, this is both hate, this is again love and hate, and this is due to the fickleness of Layla. So, sometimes this kind of relationships are also seen, and this captures that kind of dynamics. Now, our fourth case. In this particular case, you can see that this is totally positive, that is, Majnu's love depends on his own feeling and also from the feeling from Layla. So, in both these cases, it is positive. However, in case of Layla, neither she is encouraged by her own feeling, neither she is encouraged by the feeling from Majnu. So, lots of cases happens like this, that when one partner or one boy or girl started liking the other one, it's not necessarily that they get reciprocate back. So, if you want, in this particular case, I have taken the appeals to be 0, and if you want to calculate the eigenvalues, your coefficient matrix is 3, 2, minus 2, minus 3, and your eigenvalues will be 3 minus lambda, 2 minus 2 minus 3 minus lambda, and this will give lambda minus 3 into lambda plus 3 plus 4 equal to 0. So, lambda square minus 9 plus 4 equal to 0. So, lambda is equal to plus minus root 5. So, one eigenvalue is positive and the other is negative. What you will be getting is a saddle point, and if you plot them, you will get something like this. So, which means that when two peoples, they are exactly opposite, they end up in a odd kind of relationship where one loves and the other hates. So, with this we come to an end for this lecture on social science, where we have taken a model for love affairs, and you see that in these 4 various cases we are able to capture many of the dynamics that is seen in the real life scenario of love affair. In my next lecture, we will be shifting to discrete models with the help of difference equation. Until then, bye bye.